Good morning, everyone, and happy Friday, or happy whatever day it is that you're watching this video. Today we're going to be talking about geometric sequences. And so basically that pretty much answers this introduction question of, is this sequence arithmetic? It's not, because, well, what made an arithmetic sequence arithmetic? Well, if you remember, hopefully because you just had your quiz on this yesterday or 2 days ago, arithmetic means linear. So each time it would go up by a common number, which we call the common difference. So it would, be added by a common number, whatever that would be, or a common difference. So in this case, we don't have a common difference. We have, it's not like from here it's being added by 4, but then it gets added by 12, and then 36, and so on, so on, so on. So then it doesn't have a common difference. It seems like it has a common multiplier. So in other words, this is getting multiplied by 4, and then, I'm sorry, sorry guys, it's Friday. It's getting multiplied by 3. This is getting multiplied by 3, multiplied by 3. So rather than having a common difference, it has a common multiplier, which we call a common ratio. And they use R for a common ratio, and which is 3. Okay. So since it's not arithmetic, I didn't mean to spoil this for you, but this is a geometric sequence. It's a sequence with a common ratio between the terms. In other words, it just keeps getting multiplied by the same number. So if an arithmetic sequence was linear, geometric sequences are exponential. Okay? So let's do an example. Write the explicit formula for the sequence above. So we had 2, 6, 18, 54, so on. So these are very similar to, and keep in mind they want us to write an explicit formula. These are very similar to arithmetic sequences in terms of how we find the explicit formula. So it's still going to have a sub n, and you're still going to have the first term, okay, but rather than adding the common difference times n minus 1, like we did in arithmetic sequences, we're going to be multiplying by the common ratio raised to the n minus 1 power. Okay, so this is the explicit formula for geometric sequences. This is the general explicit form for all sequences that are geometric. And you just have to pretty much plug in the values. Just keep in mind, remember this n minus 1 is only given to the common ratio. All right, so, and in a minute you'll see why I am bringing that up. Okay, so we're gonna have the first term, which is 2, times r, the common ratio, which every time it was being multiplied by 3, times 3 to the n minus 1, and that is your formula. That's it. There's your explicit formula. It's honestly easier to do than to even say. So now the reason why I was saying that only the r value, only the common ratio has the n minus 1 is because a lot of people do this. When they get to this answer, they write 6 to the n minus 1. Okay? Do not do this. That's the condemned. We can't multiply before taking care of exponents. Otherwise, the order of operation police will be after you. Our Aunt Sally will be very upset with us, so don't do it. This is our final answer. Okay? All right. Now let's write a recursive formula. So the recursive formula is more so a formula to help you find what the next term would be. Now let me give you the general formula for recursive, for writing recursive formulas for geometric sequences. So to find the next term, you just take the one before it, which would be a sub n. So again, if I wanted to find the 100th term, I would take the 99th term. And what are we doing to every number? To find the next one, you just multiply by the common ratio. And you would just have to give, like a sub 1 would equal whatever. Okay? This is the formula for the recursive. This is the recursive formula for any geometric sequence. Okay, so to do this with our example, we would have a sub n plus 1 equals a sub n times r, which was 3. And for someone who dares use the recursive formula, you'd at least have to give him what the first term is. This is the recursive formula for the problem that we just did. Okay, that's it. In any recursive formula, all you're really doing is just filling in for the r and a sub 1. You're like literally you just replace this thing and you replace this thing. And that's all you have to do for recursive formula. And it's actually very similar to the recursive formula for arithmetic sequences. So just because this was on the quiz and a lot of you didn't feel like looking at your older assignments, that's supposed to be a D. This is the recursive formula for arithmetic. And you would just replace the D and you replace a sub 1. It's very similar. They're both recursive formulas are very similar. This is obviously for geometric. So again, all it does, it tells you is to find the next term, all you're doing is taking the previous number and you keep adding the common difference if you're doing arithmetic, or you keep multiplying by the common ratio if you're doing geometric. All right, guys, one more example, and then that's all. Find the 7th term of the following sequence. So now, again, these are just sequences. They're not series. We'll be getting to series on Tuesday. So they just want the 7th term of the sequence. Then write the explicit formula. Well, sometimes the wording over here can be kind of tricky. Excuse me, I'm hiccuping. Yeah, sometimes the wording can be kind of tricky. I mean, me personally, I would always just write the explicit formula first, especially if you're given some of the numbers in the pattern. So I have 3. That's all I need to know. And what's happening each time. Now, if you're unsure what's happening, if you're not too comfortable with your multiplication skills, you can always just go to your calculator and you want to divide. The best way to do this is to divide one of the terms by its previous term. So, for example, what do I mean? Well, to find what it's being multiplied by, don't do 4 divided by 20. Don't do that, because that doesn't tell you the multiplier. You want to do 20 divided by 4. That's not 20. You want to do 20 divided by 4. Oh my gosh. All right. Hi, guys. Let's start over. Hi, guys. How are you? Good morning. Happy Friday. Or whatever day it is that you're watching this video. 20 divided by 4 is 5. Okay? Now, on any problem that you would do to determine if it's geometric, I mean, you would also want to do 100 divided by the one right before it, so 100 divided by 20, just to make sure there is a common multiplier, which there is. It's 5. We got to write the explicit formula, so even though they told us to do that afterwards, I'm going to write that first. So a sub n equals a sub 1 times r to the n minus 1. And again, this is the explicit formula. This is usually what I always refer to whenever I'm trying to find a specific term. The recursive wouldn't really... you could use the recursive form, but to do the recursive, To find the seventh term using the recursive formula, you would have to know the sixth term. And to know the sixth term, you'd have to know the fifth term, and so on, so on, so on. So it's like, what's the deal? Why do that? However, there are patterns in life where the recursive formula is a lot easier to use, like the Fibonacci sequence. So there's our explicit formula. Now to find the seventh term, a sub 7 equals 4 times 5 to the 7 minus 1. So again, do not multiply the 4 and the 5 and then raise it to the 6th power. Do not do that. No. So this becomes 4 times 5 to the 6th power. And I mean, you can just do this in a calculator. 4 times 5 to the 6th. And we get 62,500. Okay, so a sub 7 is equal to 62,500. And that's it. Your homework is 10_5. All right. Don't forget we have Zoom today from 1:15 to 2 o'clock. If you have any questions on this, I hope to see you all. If not, have a great weekend. Take care, guys.